Mises and Climate Change by Clifford F. Thies, an audio daily article. The emerging discipline of climatology is an interesting one. It has no laboratory. Instead, various measurements are put into computer models to see the extent to which they are consistent with the hypothesis that human activity has contributed to the trend of global warming. Unable to conduct experiments, all climatologists can do is examine statistical correlations. In my field of economics, we have generally dismissed inferences based on mere correlations. Such things as interest rates, inflation, the unemployment rate, and real GDP growth are highly trended. Almost necessarily, they are highly correlated over discrete periods of time. This correlation doesn't prove anything regarding cause and effect, and the still short history of econometrics is littered with theories such as the Phillips curve that once enjoyed a consensus among economists that are now understood to be little more than statistical illusions. Today, the econometric standard for testing theories involves determining if changes in one variable tend to be followed by changes in another variable. Thus, the sequence of fluctuations in variables is seen as a key to discerning cause and effect. This new standard has been humbling in revealing just how complex are macroeconomic phenomena. Turning to the matter of climate change, it is pretty well established that the Earth is a bit warmer today than it was 200 years ago. Beyond this fact, there is little agreement. On the one hand, there are those who argue that human activity has been a significant contributor to this warming trend. And on the other, there are those who argue that human activity is not a significant contributor and that the warming trend has been due to natural variation. Joining in the debate, a United Nations Commission on Climate Change published a chart showing global temperature to have been relatively constant for hundreds of years and then shooting up during the past 200 years. This chart has been described as the hockey stick, with the long end flat and the short end pointed up, and as the ultimate proof that human activity is the cause of the recent warming trend. In fact, the history of global temperature represented by the hockey stick is contradicted by a variety of information. For example, the hockey stick does not reflect the so-called Little Ice Age from the 13th to the 17th centuries. I should point out that until just a few hundred years ago, we do not have reliable direct measurements of temperature and have to rely on inferring temperature from things such as the widths of tree rings and readings taken from polar ice cores. The hockey stick says that the Little Ice Age was simply local variation in climate, not part of changes in global temperature. Recently, reconsideration of the history of global climate, taking a wide variety of readings from all over the world, has restored the former view of natural variation prior to the 19th century. The new chart includes, among other things, the Little Ice Age, and tends to support the argument that natural variation explains climate change. To be sure, human activity can still play a significant role in climate, adding to, or possibly even mitigating, natural variation. The theory that connects human activity to climate change involves the so-called greenhouse effect, and involves gases such as carbon dioxide and methane. According to this theory, as more of these gases are in the atmosphere, more solar energy will be captured, which will result in global warming and climate change. Indeed, there is a high correlation between carbon dioxide in the atmosphere and temperature, both during the relatively short period of time during which we have direct measures of the two things, and during the much longer period of time during which we can only infer them. In this greenhouse view, the correlation of global temperature and the amount of carbon dioxide in the atmosphere is explained by carbon dioxide being the cause and global temperature being the effect. Therefore, if we want to stop or even reverse the trend of global warming, we should cut back on the release of carbon dioxide, methane, and other greenhouse gases, whether by us or by nature, or pull some of these gases out of the atmosphere. The contrary view of the correlation between global temperature and the amount of carbon dioxide in the atmosphere is that natural variation of global temperature is the cause, and the amount of carbon dioxide in the atmosphere is the effect. In this contrary view, natural variation in global warming affects the rate at which carbon dioxide dissolves into the oceans of the world. Since nobody argues that humans had anything to do with climate change prior to 200 years ago, it is useful to consider possible cause and effect relationships in climate change prior to 1800. In the greenhouse view, that carbon dioxide is the cause, would be the following scenario, among others. That volcanic activity periodically releases more carbon dioxide into the atmosphere than can be quickly absorbed by the oceans of the world, and otherwise, which results in a period of global warming via the greenhouse effect, to be followed eventually by a period of global cooling as the oceans gradually absorb the excess carbon dioxide in the atmosphere. In the view that carbon dioxide is the effect of global warming, not the cause, would be the following scenario, among others, that variations in solar activity, perhaps manifested in sunspot activity, affects global temperature on the Earth. Thus, when the sun radiates more energy, the Earth is warmer. The oceans are less able to absorb carbon dioxide, and there is more carbon dioxide in the atmosphere. Conversely, when the sun radiates less energy, the Earth is cooler. The oceans are more able to absorb carbon dioxide, and there is less carbon dioxide in the atmosphere. Accordingly, two plausible and in a sense opposing hypotheses are able to explain the correlation between global temperature and the amount of carbon dioxide in the atmosphere. In one of these hypotheses, carbon dioxide in the atmosphere is the cause of global warming, and in the other, global warming is the cause of carbon dioxide in the atmosphere. The view that solar activity is the cause of climate change was, in fact, one of the first mathematical theories of the business cycle. During the late 19th century, the economist William Stanley Jevons proposed the so-called sunspot theory of the business cycle. He said that variations in solar activity manifested in sunspots affected the productivity of agriculture. His one datum for this hypothesis was that sunspot activity has about an 11-year cycle, and the business cycle appeared to Jevons to also have an 11-year cycle. Unfortunately for Jevons' theory, there is no simple regularity to the business cycle. Jevons, who crossed over to economics from mathematics and physical science, was full of half-baked ideas that combined things that scientists know with economics. In 1863, he predicted there would be a serious fall in the value of gold. There followed a serious fall in the value of silver. In 1865, he said England was going to run out of coal. Yet today we have more years of proven reserves of coal than we had back in his day. That is, new discoveries of energy sources and advances in the efficiency and the use of energy have outpaced consumption. Jevons' alarmist writings about coal gained him a large popular following, as it has always been obvious to many people that we are running out of natural resources. Jevons tapped into the allure of combining pattern recognition and conjecture about causal relationships together with fatalistic pessimism. The minds of advanced animals are wonderfully able to infer patterns from data, to interpolate within the data where it is missing, and to project out of the data. This enables members of the animal kingdom to make order out of the mass of data encountered by our senses, as when, for example, a frog catches a fly by zapping out its tongue upon seeing motion in its target area. The human mind is furthermore disposed to reasonable arguments as to what explains the patterns it sees in data. This ability gives us our unique characteristic of being volitional or moral creatures. Thus, Ludwig von Mises differentiates the study of human action from other scientific disciplines. Water does not choose to flow downhill, and the observation that water flows downhill does not reveal that water has any preference in the matter. But human action involves choosing, and must necessarily involve some theory of cause and effect. Furthermore, human action often changes in ways that are surprising to those who fatalistically and pessimistically extrapolate whatever trends they observe to the conclusion that we are all doomed. This is because almost all people choose life. Thus, long before the current global warming scare, Mises wrote, "Some philosophies look upon life as an absolute evil, full of pain, suffering, and anguish, and apodictically deny that any purposeful human effort can render it tolerable. Happiness can be attained only by complete extinction of consciousness, volition, and life. The only way toward bliss and salvation is to become perfectly passive, indifferent, and inert like the plants." It is one thing to be concerned about the possible impact of the sum of many tiny human actions on the climate of the planet on which we find ourselves, for this is entirely consistent with choosing life. It is quite another thing to presume that we are doomed unless, whatever we are doing, we stop doing it right now.